the whiteboard. So you get to do the writing.
Yeah.
I mean, that's good. So then we could just do X plus 5 bottom.
Okay, yeah.
Yeah, like 7 whole. The top would have to be, the bottom would also be X.
And then
Yeah.
The final one. Did they already, I started with X and reconcile, and then I, like, and then
She just told us that. She's not even here to have that tomorrow because we're on her final. Just tell us that before.
so one group has that.
Oh, wait, it's one about me. I forgot.
Okay, I want one equation, so like. So far, these are the things that I see on different people's boards. So you have the same thing.
It's the same as the first equation.
Same as the first equation. And this one's a little different. What else do we have? This is same as the first one. Who's did I steal yet? But is it the first thing as the first one? Okay. So, what's in common, what's different? So let's look at this. Horizontal asymptote of y equals 7. I think that's why you guys all have that 7. So that 7's needed, and the lead coefficient that's going to be in the denominator for all of these is a 1. Okay, for it to be a horizontal asymptote, the exponents needed to match. So let's see, I have 1, 2, 3 x's on the top, 1, 2, 3 x's on the bottom, so this will have a y equals 7 that will work. 1, 2, 3, and then 1, 2, 3, 4. This one is gonna have a horizontal asymptote of y equals 0. 1, 2, 3 over 1, 2, 3. This one is gonna have y equals 7. And this one is gonna have y equals 7. So this one, there's an extra x down here that shouldn't be there. I might have copied it wrong. So, vertical asymptote of x equals 0. So, actually the whole is easier first. Because it said there's a whole at x equals -2. You needed a factor of x plus 2 over x plus 2 in each of these. And we have that down here. Factoring the 7 out, it's an x squared minus 2. It needs an x on the 14. And now with it factored out, so all of you got the whole, correct. Are you at all? Sorry?
That one is an x squared plus 3x minus 15. So x plus 5, x plus 2 can equal 15.
The denominator here factors to the x plus 5 times x minus 2. Sorry, not 2, minus,
It should be minus 3.
3. So it doesn't match. So it doesn't work. They got fancy and multiplied it out. But this made the whole in all of them. And then the vertical asymptotes, the things that are left, the factors that are still there. Spencer, yeah.
Why would x, like, before you had x minus 2 and x minus 2, why would that work? Because wouldn't that be x equals 2? Not a negative?
Yeah, this doesn't work. But then I needed 2 more factors in the denominator to be there to make those asymptotes. So an x and an x plus 5. Why plus 5? Well, I needed that factor to be this. So I get this guy, I get that guy, get that guy. They wrote x minus 0. Did they need the minus 0? No. Is it wrong? No. So that, okay? It's asking you to go the other direction and see if you understand what's going on. Okay. Homework today is Delta Math, and what I want to do today is have you guys as groups put problems, the worksheet from yesterday. I want you to put the problem up, and then I'm going to have a different group explain your work. So your work, first of all, there's calculus all over the board, and you guys are going to have to erase that. But they wrote teeny tiny. Could you guys write large enough so that Mayuna in the back can read what's on the board behind Ella? So, like, write it large enough. It's not like the height of your body, but big enough. So, the worksheet from yesterday is this. I did the work for number 1 already, so this was the first question, and it took us to here as the second question. So here's a picture of all the problems from yesterday's worksheet. So group 1, can you put up your work at space A? Group 2, for this one, can you put your work up under space B? Group 3. Then group 4. Hold on, I gotta make this space.
Where would you write it?
And I'm out of space, but so groups 9, 10, and 11. So groups 9 and 10 up here, group 11, you guys get this board itself. So, people that are not up with their group, you should be up there making sure that they're right. And Jonathan, you shouldn't be doing the writing. Yes. Alicia, you're up here too, so you guys are on the board itself. Yeah, we're doing that. So, you guys are this one.
We're 11.
Yeah.
Where's 11?
Right here.
Oh, we do it on the board? Oh.
But I'm gonna steal this.
Oh, yeah, right, sorry. Hopefully,
So,
oh.
Megan and
So
Tim
it's
are
not-
group 10, you guys are
Okay.
okay, 9. So, you know what? Emmy, you should be up here.
Okay, I don't know. So it's like 4 over. Yeah.
So, you guys are ready. Hold on, let me scroll up a second so we can see which one. You guys have that one, good?
Oh, I think I'm starting from. No, I'm not.
You're doing this one.
Okay, now we like multiply this whole thing by k minus x and k minus x.
I thought they would all cancel out.
Yeah, that's what I'm thinking too. So like if we multiply this, all this over here, would we be just left with k plus 1?
I think it's fine because like all the they all match up. So this one.
Okay. So like if we multiply these and on these
Yeah, we could do.
onto that side, would we be left with 4 equals k over plus k plus 1?
I think they would just all cancel out. Like I don't.
Yeah, the bottoms will cancel out, so we'd be left with 4 k plus 1.
Alright, so should we multiply that?
So
Grab a marker from someone's
k minus 2 and then
Charles, give the pen to someone else so that they can write it larger. Give the pen to someone else.
And then you multiply by that. Okay.
on this whole
Give the pen
side.
to someone else, make them do some work.
I didn't do anything. Or my handwriting's.
Is that okay?
Yeah,
Okay. Oh, it's up there.
plus 1.
And I'll give you Okay.
And then k should equal 3, right?
Do the multiply. I did. I reduced it.
But what I don't get is if we multiply all this onto this side, right? This would cancel out. But over here, if we multiply this whole thing, wouldn't the k minus 6
multiply to this if they don't have.
Actually, no, because you're also doing, like, you're not setting it like equal to 1. You're not doing like k minus 2 over k minus 2.
Because it's like the whole equation we're multiplying on, right?
Yeah, if we did that, like we're multiplying it by 1. So it's like only
I'm really hoping so. Miss Pascal, do you mind if I ask you a quick question? So, I just don't understand, like, on here, I got it wrong, but when we did it together, I think we got it correct. But, like, when you multiply these two denominators on this side, like, it cancels out, or does it?
Not entirely. So I'm not able to follow your work very well because so much stuff is crossed out. So, what are you multiplying by? You're multiplying by the denominator, you're not just multiplying by k minus 2. And writing it down here implies you're multiplying to the bottom, but you're not.
Ever since they created like all like the all stars.
So if you're multiplying by k minus 6, k minus 2 on this side, over here,
We have really good players.
k minus 6, k minus 2 to everybody. So this stuff does cancel out and becomes that 4. But over here, k minus 2 cancels, but k minus 6 is still there. So there's so much stuff.
But when I did it like that, I got like a factor equation. Like I got like x minus 6 and x plus 1.
So, yeah, it's not an easy zero. Okay.
Sorry, I think that was
All right.
Okay.
I have a question.
Yep.
So,
I didn't catch that. Okay, we're just gonna like guess, I guess.
Some of them
So
will
this
say
definitely
either
said
rotate
what
or
says
rotate.
when you have
Yeah.
yeah,
But this would be like a note section where you see
Yeah.
that says like original and retake.
What's the average?
plus
Not everyone, but
Oh,
2.
I don't know anyone who.
Wait, is this squared?
I thought I understood.
So now we're now we add the 2 plus. Oh no.
I was like, so how do you do like?
Yeah, let's do
Did
first.
the opposite thing. We found this line that
I knew that I missed like what's our like
Oh, these are. That's what we're left
that was the
with.
problem.
Do you remember?
But like that's why I got like
It was like, I want to see mine, so I just did the
I
last
noticed
added.
it, but then because I was calculating it as I
And
was
then you
doing
can
it.
set
I noticed like what you factored to. So if I
X
get
minus
like
6.
X like all these like slants or A, but then that would be like. No, you're. I thought it like. I don't just. I don't know.
Oh, I get it. So this should equal -1.
yeah. Okay, I messed this up.
It's okay.
Guys, you should be looking at what other people did, because you're gonna have to explain.
Okay, whatever. Okay, x minus 6, x plus k plus 1. And then that's
And then I think x should equal -1
equals negative.
because you can't plug back in the 6.
Can't plug in 6.
I feel so bad for whoever's gonna do this, bro. It's like
Okay, so I want to look over these. All right, so this problem is written over there. So, group 2, can you explain the work that they did here? What, not group 1 wrote it, so group 2. Can you explain what they did first? Like, just from your seat, like talking? Chloe, did you guys write this up? These guys wrote this up, okay. It's hard to see. What's the first step that they did? They multiplied by something. What did they multiply by? What did they multiply by? Can you see, can you read their work? Can you understand what's happening? So they multiplied both sides, all the things on both sides, by b minus 2 and b plus 2. And they made it crowded because they wanted to make sure that you saw that they were multiplying to that 2 as well. And then they got rid of denominators. So for this one, the b minus 2 went away with that one. Nothing canceled in this one. And over here, we were left with 3b minus 2. And then they did a lot of stuff. Put the computer away, Holiday. Thank you. They expanded, did a lot of algebra. Yes, Cameron.
Wait, so are we trying to make the bottoms the same? So I keep
Okay.
forgetting using them between the solving and the other.
Now we have an equal sign. We can just multiply. Ella, can you put the computer away?
Like, what would happen if you? Oh wait, I see. Never mind.
Okay. So in the end, they do all their algebra. The b squareds cancel out, and they got b equals 1. The work is over there. Do you guys agree with that answer from what you have written on your own work on your paper because it was homework? Is it b equals 1? Arden agrees. Jonathan agrees. Lucia agrees. Okay. So, the next problem. This one. So group 3, looking at what group 2 did, what did they multiply to make stuff go away? So what I see is
Doesn't look like it's
that they multiply by 3x minus 2 only.
That was by minus 2 and plus 2.
So they needed to also, Lucia, you're right, why did they also need the 3x plus 2?
Because they're trying to make the bottoms the same, so one is minus 2 and the other's plus 2, so they did by the opposite.
So we're not exactly making the bottoms the same, but we need to make them reduce. So this front one becomes 4x times 3x plus 2. And then this is 2x times 3x minus 2. And then over here it's gross. But at this point, it's now just algebra. You need to be able to distribute things out. Yes, Spencer?
Can you explain how you would, like, factor out everything with 2 times 3x minus 2 and 3x?
How we multiply things out?
Yeah, because that would, like, I got this.
Okay. All right. So, guys, algebra from here. Distribute to everybody. What's 4x times 3x? Naomi. 12x squared. Boaz, what's 4x times 2? 8x. Nate, 2x times 3x.
6x squared.
Joaquin, 2x times negative 2.
Negative 2x.
2x times negative 2.
-4x.
Negative 4x. Over here, I'm gonna do this multiplying side first. So Ally, 3x times 3x,
9x squared.
9x squared. Ella, 3x times positive 2.
6.
Cameron, negative 2 times positive 3.
-6.
Negative 6
X.
x. And then Dylan, negative 2 times positive 2.
-4.
Negative 4. So, all right, those 6's go away, positive 6x and negative 6x. Combining some like terms, 12x squared and 6x squared, 8x minus 4x is what I get on that side. On this side, distributing the 2, 18x squared and negative 8, 2 times that, negative 4. What happens? Sorry, Dylan, yeah.
Isn't 8x minus 4x positive 4x?
Yes, it is. But no, what happens now with the stuff in purple? Okay, how? Like, which things would you move?
The 18x squared on the
How do I move it? So when I subtract 18x squared from both sides, Samara, what happens? They cancel out. And I'm left with 4x equals negative 8. Ha. Last step to get. Arden says divide by 4, so you get x equals negative 2. Yeah? Okay. Kind of a mess on all these. So you definitely needed more space than was on the paper. This one, the very last bottom right on the back of the page, they are showing that they multiplied by this, and that happens to be those two things factored together. So they multiplied by k minus 6 and k minus 2, distributing things out and reducing. They got 4 equals a mess over here, k times the x minus 6, and then 1 times the k minus 2. And they only got negative 1. How come they didn't keep, in factoring, they get x equals 6 and x equals negative 1. They only kept the negative 1. How come? Why? Okay, so those that wrote the problem up say we threw it out because when they plug 6 back in to this problem, it causes a divide by 0, which is a problem. So they are right in throwing it out. So let's see, what did you guys get for this one? They got b equals 1 here. This one, did we finish or not? I don't know that we finished. This one we got k equals negative 1, which takes us to this problem. Which ones were especially hard? They're all over the boards. Which one should we talk about next? Are you guys all good and fine and you're great with solving rational functions? Yeah.
Should we go over average? Average
Okay, yours is which one?
is the point one, so the one that's our answer is negative 19.
Okay. All right, so they say this one was kind of hard. Oh. Suggestions how to start? Emmy? How to start this one?
multiply by r squared
minus 2r. Okay, so I'm going to multiply it to both sides,
This is the one.
and I'm going to keep parentheses on it. So Samara, when I distribute it to this first piece, I have r squared minus 2r multiplied to r plus 5 over r squared minus 2r. What happens right there? Yep, and we get an r plus 5. Okay, now distributing this to the second one, minus 1 times r squared minus 2r. There, I gotta be careful because it was a negative. So Joaquin, what does that mean I gotta do? What do I do with this guy? I had a negative. It's a mess. How do I distribute it?
Flipping it.
By flipping the sign. So I get negative r squared, positive 2r. And then somewhere again on the other side, we get equals what happens? Does it go away and become 0? Cancels again and it turns into 1. Okay, and now this is algebra 1, which seems to be most people's nemesis. Dylan, how do I do algebra 1?
Isn't it just factoring as well?
Yeah, can I factor it right now in the condition it's in?
Probably
He's
not.
going like no.
No, but couldn't you subtract the 1 and then solve for 0?
Okay, I need an equal 0. That is true. As a math teacher, I do not like factoring with that exponent, or I don't like that being negative. So even though there's only one dude over here, I'm gonna move everybody to the left. Because I do not like this being negative. So I'm gonna add r squared to both sides. What else do I need to move over?
The 5.
How do I move the 5?
Subtract by 5.
What else am I moving?
The 2r.
The 2r and that r, so,
Wouldn't you just leave the other r though, so that you're solving for r?
nope. So over here, r plus 2r minus 3r, I get 0. Remember, I need an equal 0, is why I don't leave it. Over this side, I get r squared minus 3r, and then 1 minus 5 is negative 4. Does it factor? Charles, does it factor?
Isn't it x minus 3 x plus r minus 3 r plus 1?
Needs to multiply to be 8.
Negative.
So either r equals 4 or r equals negative 1. Spencer, do both answers work? We go all the way back to the beginning. R equals 4 and r equals negative 1. Do they both
Yeah.
work? It looks like it. At negative 1, I get 3. And at 4, sorry, negative 4 or positive 4? Which do we have? Positive 4. Get 16 minus 8, so yep, both work. And, Beckham, which was the one that you guys were working on? What does it say as the little answer over its box? The negative one? So up here, that one. So they were struggling with that one. But, sorry, Samara, okay with that? Any other questions with that one? Okay, they were working a long time on this one, and, let's see. Here, how did you guys start on that one?
Both of the sides by, like, x plus 3. Like we multiplied the first side by x plus 2, x plus 2. And we multiply the other side by x plus 3 over x plus 3.
Okay, So you're finding a common denominator, all right? Which we can do. So up here, multiplying those together, x squared plus 2x minus 4 over x plus 2, x plus 3. Minus 1 is still there. What do we do from here?
From there, you try to get rid of the denominator. Or
How?
You by multiplying both sides by the same, well, with what it doesn't have.
Okay, so what did you multiply by at this point?
X plus 2 and x plus 3 on both sides.
So on both sides, x plus 2, x plus 3.
And then the denominator shall say x plus 3.
Those guys go away, and I have 3x plus 9.
Yeah.
Distributing this, there are two pieces here. So I keep seeing that you guys are ignoring the fact that there is a minus 1 that has no denominator. It's not a,
Well, we changed the minus 1 to be x plus 3 over x plus 3.
but it's not, I mean,
Because it'll just be like negative 1.
okay. So you did that? All right. We're multiplying this to this first guy. The denominator cancels and I get x squared plus 2x minus 2x. Those guys go away. So x squared minus 4. Multiplying this to this one, I get minus. What's left?
X squared.
What is it?
X plus 3 cancels with,
So this goes back to becoming a 1.
yeah,
But when I multiply this to it,
x plus net minus 2.
it's x plus 2 and x plus 3 in there, right?
Yeah.
To here.
Because you multiply both by 1.
So I don't know that it was helpful changing this to be x plus 3 over x plus 3. It's a 1. 1 times this stuff is all of that stuff. Ella, can you help us multiply this out in here? X times x? X squared. X times 3? 3x. 2 times x? And 2 times 3?
6.
Cameron, how come I put parentheses around it and didn't just copy it all?
Because you still have to multiply it by both of them, or just the, oh, it has to be negative, it all has to be negative.
I need to flip everybody's signs in there. X squared minus 4 minus x squared minus 5x minus 6. Oh my goodness, longest problem ever. That's why it took a while. Tessa, cleaning things up. What cleans up in here?
You would move it all to one side, so you can subtract it on it and subtract 3x.
Okay, well, let's look on the left first and combine some like terms. Does anything smush and go away?
The x squared goes away.
X squared and negative x squared. Okay, and then I have negative 5x minus 10. So do I need to move everything to one side? Or can I do x's to one side and numbers to the other?
X is to one side and this.
Why is that the better choice right now?
Because then you don't have like a whole like long list of like equations, and then you can easily reduce things down. So
Okay.
With the minus 5x, you just subtract 5x from both sides.
But like, so how do we know when, like sometimes we want an equals 0 and sometimes we move letters to one side and numbers to the other. How can we tell the difference? Charles, any idea?
If it like, if it has an x squared, then it's usually minus equals 0.
If it's a quadratic, if it's anything other than something linear, you need to move them all to one side and get that equal 0 in factor. This one, add the 5x to this side, subtract the 9. Negative 19 over 8. Please do the delta factor.